Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shen, coming to you live from Summit Academy. In this video, working on Unit 8, Lesson 8 as well, talking about that Pythagorean theorem with right triangles. And so it says, which one doesn't belong? So in this one, we can say that for this one, B isn't isolated. It's not by itself. For this one term is on the left all by itself. For the third one, it's the only one without the 3, 4, 5 Pythagorean triple, meaning those side lengths form a right triangle. And then this one, only one without a variable. For the next part, for number 2, it says label all of the hypotenuses with a C. So again, make sure it is always opposite of right angle. So in this first one, I could say, hey, across from it is C. However, in B, I know this is not a right triangle, so I can't label it a hypotenuse. For C, you can say it's across from it. For D, across from the right angle, across from the right angle, and across from the right angle. For the third part, it says find our length of C. So I use that Pythagorean theorem. So I'm going to say I have a squared plus b squared equals c squared. And I can say, well, this is that side length of C, which is already labeled. So this is going to be the longest side. All right. So let's say plug in our values. So I have the square root of 10 squared plus the square root of 40 squared is equal to c squared. So this is going to be 10 plus 40 equals c squared. And so that means that this is going to be 50 equals c squared. But we have to find that side length c. So we take the square root of both sides and we make sure that we say, again, c is going to be equal to the square root of 50. And we can leave it just like that. The next part, same idea. We're now looking for that side length b because the square root of 26 is the hypotenuse. So we're going to say same setup, use that Pythagorean theorem, plug in the values that we have. So it's square root of 8 squared. We don't know what b is, so we leave it unknown. And c is going to be the square root of 26 squared. So this is going to be 8. This is b squared, and this is 26. Be able to subtract, so I subtract 8 from both sides. Get b by itself, so we have b squared equals 18. And so we take the square root of both sides, and we say b is going to be equal to the square root of 18. For number 3, it says a right triangle has side lengths of 2.4 and 6.5. What is the length of the hypotenuse? So you have to draw out the triangle for yourself. Again, you're looking for that side length C, so this can be 6.5 and this can be 2.4. Use that Pythagorean theorem, so we have a squared, b squared, and c squared. Plug in your values, so I have 6.5, and do it in order. Let's do 2.4 squared plus 6.5 squared is equal to c squared. So I say this is going to be 5.76 plus 42.25 equals c squared. Add these two together, so that's going to be 48.04 equals c squared. And so I can say c is going to be equal to the square root of 48.01. Same idea for the number 4. I can draw out my square. Let's try that out again. A little bit better. This time it gives us the hypotenuse, which is 1/3, and it gives us a leg, which is 1/4, and we're solving for an unknown side length. So that can be A, that can be B, either one works. Make sure you plug in your values. So we're going to say A squared, B squared, C squared. So we have 1/4 squared plus B squared equals 1/3 squared. And so this is going to be the same as 1/16, which is, so let me write 1/16, which is the same as 0.0625. We don't know what B is, but we can still solve for it. So we're going to say this is 1/9, which is the same as 0.1 repeating. So make sure you're saying that's repeating. Subtract both sides by that amount. So subtract both sides by 0.625. And we can say that B is going to be equal to, we can say B, B squared, still B squared, is going to be equal to 0.0486 with the 1 repeating. And we're going to say, take the square root, we're going to say B is going to be equal to 2204 with numbers after it. So as long as you have, those first few decimal places, I'm good. For number 5, it says find the value of x. So first what we have to do, find this value of a, because we need to draw our right triangle. So I'm going to say like this, I'm going to have 5 squared plus a squared equals the square root of 34 squared. Make sure you evaluate those carefully. Again, solve for the missing side length. Make sure you can use those inverse operations to get a by itself. That's going to be a squared equals 9. Take a square root, a equals 3. Make sure you're not saying that's your answer yet, because we need to find and solve for x. So this is going to be 3. So now we can say it like this. We have x squared plus 3 squared equals square root of 18 squared. So we're trying to solve for x. Should get it by itself. So we subtract 9 from both sides. So we end up with x squared equals 9. Take a square root, both sides. And so we can say end up being the same, but not always true. We end up with x equals 3. On the back for our lesson 8 practice, it says find the exact value of each variable that represents a side length in a right triangle. So for h, so actually I would say I'll set up, I will solve for h, you finish the rest. Okay. So I will solve for this first one, but I need you to try to solve for the others. This is helpful because I can say that this is my side length c, so I can have h squared plus 8 squared equals 10 squared. So I have h squared plus 64 equals 100. Subtract both sides by 64. Trying to get that h by itself, but we need to make sure we get rid of that exponent. So this is 36. Take the square root, both sides, and we're going to say h is equal to 6. So now I want you to pause, and finish. For the next one, it says a right triangle has side lengths A, B, and C units. The longest side is C. So we know it's a right triangle. We know the longest side is C, and so it's just basically asking us to rewrite the equation. So we can say this is the same as A squared plus B squared. For this one, it has to be the longest side minus the other side. And we have to say this is longest side minus other side. So that one's real easy. This is just rewriting Pythagorean theorem. Let's try that H a little bit better. All right. For number 3, next one after, it says what is the exact length of each segment. So you can use your Pythagorean theorem to be able to solve it, but I could say, well, this one we can count, and this is just 4, so that one's real simple. For this next one, what I want you to do is draw right triangle and use A squared plus B squared equals C squared. So like this, I'm going to say that, hey, my right triangle formed. Again, a couple ways you can draw it, but I'm going to say that this is going to be a 2x4 triangle. So now I can say I have 2 squared plus 4 squared equals m squared. So this is going to be 4 plus 16 equals m squared. This is 20 equals m squared. So that means that m is going to be equal to the square root of 20, which is about approximately 4.47. Same setup with the next one. Draw out your right triangle. Let's try that again. Like so. This side length is 5, and this side length is 4. And so I can use my Pythagorean theorem like this. I'm going to have 4 squared plus 5 squared equals q squared. So that's going to be 16 plus 25 equals q squared. So this is 41 is q squared. And so we're going to say q is going to be equal to square root of 41, which is approximately 6.4. So notice how, again, for each of these, the side length was the longest of those 3 sides. And lastly, at the bottom, it has that little exit ticket for you. It says a right triangle has 3 sides, 3, 4, and x. And now it says 2 different situations. Find when x is the hypotenuse. So it should look like this, x, 3, 4. And for this one, it's going to be when x is one of the legs. So this is 4, and the other one is 3. So again, be able to solve for x. So you finish by solving for x using Pythagorean theorem. Again, be sure to ask questions, be sure to replay and rewind as needed, and as always, super slam that subscribe button.